Hi, so welcome to this problem number 1001 grid illumination. It's a lead code hard problem, but I would not put this in the hard category. It's medium level problem. It requires a few insights, but it is not as usually a hard, such a hard problem like we do in the generally in this playlist. So the question is, that you are given a grid of size n cross n, and each cell of the grid of the grid has a lamp that is initially turned off, right? So you have these n square lamps. All of them are arranged in this n cross n grid, and each of these grid has all the lamp. The lamps are turned off, right? You're also given an array of lamp positions, lamps, where lamps I row I indicates that the lamp at grid row I this ith row ith column is turned on when a lamp is turned on. It illuminates itself. So basically you are given these this array, and each of the array contains this two tuple and column. So in that row, that column, the lamp is lit, right? Now when the lamp is turned on, there is this other condition also. What is the other condition? When you turn the lamp on, it illuminates its cell and all other cells in the same row, same column or diagonal, right? So if I, let's say if this is the grid, and I turn like this lamp, a lamp here up, all the lamps which are here, all the lamps which are here, up, down, and also sideways, right? All of the lamps would be lit because I lit this lamp up, right? So this is the catch. This is the interesting part, that when you have a lamp which is on, it illuminates all the other rows in the same, like all other lamps in the same row, column, or diagonal, right? So this is the setup. You're given many of these, this array lamp. Each of them you indicates which lamp is on. So it itself is illuminated, and all the column, row, both of the diagonals are illuminated. Now the question is that you're given this query array, right? Where queries of I is also a row, comma. So I'm actually, this is a query array in which there are different queries. It's querying the grid, and a query is like row, comma, column. And for the ith query, we need to determine whether the lamp at row I, column I is illuminated or not, right? Not just that, what it says is that after answering the ith query, you need to turn off the lamp at grid row column, grid, that row which you queried, if it was on. And basically its 8 adjacent lamps are also on if they exist. So basically every cell would have, 1 2 3 4, and then 5 6 7 8, like 8 neighbors every cell will have. So all of the 8 neighbors you have to turn off, right? So if the lamp is on, right? If the lamp is off, then we don't need to do anything, right? So what are we doing? For every query, we are first telling whether the lamp is on or off at that position. And if the lamp is on at that position, you switch off the lamp, and you switch off all the lamps which are in the eight vicinity lamps adjacent to that, to the lamp which is being queried, right? And then you need to return an integer answers, where each answer I should be 1 if the lamp of the ith query was illuminated, and 0 if the lamp was not, right? So this is more like a sequential problem. So first query, it does not only query the grid, but it also affects the grid. So it changes what is on and off in the grid, and the next query, it affects, so on and so forth. So it's more like a dynamic, querying problem. So where, if this was a bunch of queries, what we could have done is we could have really, made some arrays, stored the states of the grid, and then just sequentially queried everything. But this is not about sequential query. You would have to store everything in such a way that while you are querying, you are going to update it so that the next query would be possible, right? So that is the tricky part. That is the challenging part here. So let's just see a few examples, right? So this is the first example. uh, yeah, let's zoom in a bit to see. Yeah. So in the first example, this is the configuration of the grid, and there is um, this is the configuration of the grid. And so we'll see what the input is given. The input is input is this n. Input has n is equal to 5, so it's a 5 cross 5 grid, so it's a 25 bulb grid, and at least this arranged in this way. So the on lamps are 0 comma 0 and 4 comma 4. So now you see 0 comma 0 is the lamp which is on. So when you say 0 comma 0 is on, it switches off all of its rows and all of its columns and all of its rows and also all of its diagonal, right? Yes. So this is switched on and this is switched on, and then this is switched on. So this is when you look at the first one, 0 comma 0. Now also 4 comma 4 is also added. So what is the 4 comma 4? So this is 0 comma 0, this is 1 comma 1, this is 2 comma 2, 3 comma 3, this is 4 comma 4. So 4 comma 4, this lamp will illuminate this row, this column, and the diagonal. Now because of this, these things are already illuminated, so we just keep them on, right? So that is not a change. So the queries would be 1 1. So okay, so when we do like 1 1, what will happen is that this is, so we want to switch this off, so this is off. And so the answer vector is 1, because the at this position at 1 1, this lamp was already on, and then we switch off this one, you switch off this one, you switch off this one, this one, both these are already switched, and you switch off this one. Now 1 comma 0, right? So we're looking at the first row, and the basically we're looking at the first row and we're looking at the second column. So we're talking about this lamp. Now this lamp was actually switched off because of the last query, so we don't need to do anything, we just return a 0 because this is switched off, right? So you see, in the first query it was something else, and then it updated in the second query and we were able to return, right? So same happens. So this is just gives you this example that, in this rectangle it is of this is the same thing, right? So we have to start programming with this situation in our hands, right? So the interesting part, sorry, I did not want to print anything. Yeah, so I did not want to print anything. The it's I just pressed that by mistake. Now let's look at this problem. Now the interesting part is that we need to have a proper data structure which we would use to do the updating, right? So the key observation we have is we have to store the positions of the lamps such that they are easy to update. Now if we, let's say if we made a set or made a vector of vectors and just stored the lamp positions individually, so like for every lamp which is on, we just iterate through the rows, columns, and the diagonals, and we stored them manually in the array. What the biggest problem that would have happened would be that, if you wanted to do the updates and the queries would not be efficient, right? Because the query might be efficient, you would say whether the grid is on or off, but if you wanted to update there would be a long procedure where we actually iterate through the entire vector of vectors, we see there are a few conditions satisfied, we determine what is around, and do it. So also there's another added challenge that we need to find out, to find a way to iterate through the diagonals, right? Because x and y coordinates is easy, but how do you actually iterate through the diagonal? So all of these are actually questions one can ask and one could pose. So the natural way of thinking would be that rather than storing this as individually in a vector of vectors, the position of the lamps with, what you could actually do is you could just store the x position and y position and query accordingly, right? So the key idea is to store just the x position is like the row, and y position, which is the column position, and then query from there. Now how do you do that? So for that, so x position, y positions are enough for querying whether they're in the same column or in the same row, but how do you even look at the problem of the diagonals? So could you represent the diagonals with this x and y? The answer actually turns out to be that yes, you could actually do that. Let's go on a whiteboard and see how you could actually accomplish that. So we I just like erase the screen. So assume we have this square grid of a certain size. For example, it's 4 cross 4, right? It's 4 cross 4, and it's a little bit abnormal, but just forgive me for that. Yeah. So this is this 4 cross 4 grid, and what we have here is, let's write the individual coordinates of these things. So this is 0 comma 0. This would be you know 1 comma 0, depending upon row, or like the first one was like row, right? So this is a column, so this is 1 comma 0, depending on whatever you want to do. The observation still holds. It's 2 comma 0, this is 3 comma 0, right? uh, this is 0 comma 1, this is 0 comma 2, this is 0 comma 3, right? And so on and so forth. This is 1 comma 1, this is 2 comma 2, this is 3 comma 3, uh, this is 1 comma 2, this is 1 comma 3, this is 2 comma 1, this is 2 comma 3, this is 3 comma 1, 3 comma 2. Now, like in this setup, let us figure out how do you query, like let's say certain. So for example, you have this this lamp is on, so you save 0 and you save 1. Now when you save 0 and when you save 1, what happens is that any of the any of these which will have the x coordinate as 0, they would be lit, right? So you don't need to figure out, then you don't need to store all of these values individually. If you've just stored the 0, which means that if this is on, anything with the left side as 0, anything with the row value as 0 is already on. So you just need to store this 0 and then check for it. The second thing is anything, this entire column will, like this entire row would be lit. So anything with the position 1 in the right side, which is the column position, row position, whatever, like the right side position, these things would be these things already will be lit. So we just have to see, we have to store the x value, we have to store the y value, and for any incoming query check, if we just check the x and the y values, and if you've seen things before, then I feel we are done, right? That is what we have done with the rows and columns. But the question is, what about the diagonals? So now diagonals are of two types: the diagonals which go from here to here, and the diagonals which go from here to here, right? Now the diagonals which go from this side to this side, they are called the primary diagonals, right? They are called the primary diagonals, and these are called the secondary diagonals, the which comes from this side. If you observe a pattern in the primary diagonals, this entire thing becomes very, very easy. So take any primary diagonal. Let's say we take this diagonal, this primary diagonal here, right? So what is 2 plus 0? It's 2. What is 1 plus 1? It's 2. What is 0 plus 2? It's 2. So the x plus y value, the x plus y value in the primary diagonal would remain the same. Take any primary diagonal. Take this one. 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. So the x, like the x plus y value in the primary diagonal remains the same. Now take any secondary diagonal. For example, let's say this one, this big secondary diagonal. Wait, let me use a different color, right, to say this is, let's say we're looking at this big secondary diagonal. Now in this big secondary diagram, the diagonal, what we do is we just subtract the values. What is 0 minus 0? It's 0. What is 1 minus 1? It's 0. 2 minus 2? It's 0. 3 minus 3? It's 0. So the secondary diagonal would preserve x minus y, right? So if you want to check the row, what you need to check? You need to check the first value. If you want to check the column, you check the second value. If you want to check the primary diagonal, you check the first value plus the second value, get the x plus y. If you want to check the secondary diagonal, you check x minus y. You could like verify it with anyone. Let's say this one, 0 minus 2 is minus 2, 1 minus 3 is minus 2. Take any of them and it will work. It will work for an n cross n grid, and it is that actually not that hard to show. You could actually use a piece of pen and paper and just see what it says. Once we have done this, I think the problem is now extremely simple, right? Let's do this together now. So we have this vector of int, let's call it answer, right? And it's currently, it's where you'd return the values. Now vector of int is answers. Now if any case, if n is equal to 0, what we do is we just return this empty list, because there is no bulbs to check. If this is not the case, then we have interesting things. What we do is we would want to store the x values and the y values as unordered maps, right? Unordered map of int comma int, right? The two values x and y, and int comma int. Let's call this x. Then there is this unordered map of y, right? It's just y. We also need to have an unordered map for the primary diagonals to check the x plus y. So we have an unordered map of int of, let's say, p diag, right? And we have an unordered map for the secondary diag. Cool, easy. We also need to have a set, a simple set which would store for example, it will store which values there are. So the like for example, if this was row comma one, so you'd actually also need to store the input queries so that we can then remove them from the set. So row, like the lamps, where are all the lamps, so to see where all the input lamps are, right? What you do is just you do pair of int, so it's just a set of pair of int, and that's it. We call it, let's say, s. That's a good name for a set. Why is this not being indented properly? Because if there is an indentation problem in Leetcode, always remember that you might have done some syntax error. So that's a good hint to take from Leetcode, right? So set pair int s. This is good. Now what we want to do is we want to iterate through these lamp vectors. So for auto lamp in lamps, right? What we need to do is it would be a 2D, like it would be a two element array. Now you just say x of lamps, of lamp of 0. So the first value of that, you just say plus plus, because I've seen like the unordered maps x and y will store how many times have I seen this x to be like this x in my input array. So you'd see where this is used in the future, but it is like if I've completed all the instances of x where x was supposed to be plus, then where x was supposed to be there, then I mean that this entire row is empty or that element is empty. So we'll have a look at that in the subsequent programming. So for the yth lamp, we have seen y once. We also need to see where we have seen the primary diagonal. So we do the p diag, and p diag is of course lamp of 0 plus lamp of 1, and we would want to do plus plus. We would want to increment that, and the secondary diagonal is nothing but the same thing with a minus, right? With a minus. We would also want to secondary diagonal. We also want to insert the values in the lamp values in the s set. So you just do s dot insert, uh, have the curly bracket notation, lamp of 0 comma lamp of 1, right? Done. So when you do this, what happens is that this entire loop will run and it will increment this x on map, y map, diagonal maps, primary diagonal, secondary diagonal, and it will increment so that every time we see an x and a y, every time we see a point which is illuminated, we know where or the others are illuminated just by storing the instances in a map. So now this is done. Now for auto query q in this queries, what we would want to do is we would want to, let's have some real estate. What we would want to do is we would want to do q of 0, q of 1. So we want to first see whether these things are in, whether this q is actually matching in the lamp. So how do you do that? You just do if, for example, let's say if we just want to check whether this q of 0, q of 1, which are like the x's and y's, do they belong to any of these things? Yes. So for that, what you do is you just do if check if x of q of 0, of course, if this is greater than 0, or like if any of the condition holds, if it's in the row of this one, if it's in the column of this one, right, is greater than 0, if it's in the diagonal of this one, p diag of q of 0 plus q of 1, if it's in the diagonal of something, it's greater than 0, or if it's in the secondary diagonal of something of q of 0 minus q of 1, if it's in the secondary diagonal, then we can say that if any of this is true, what we do is we now know that this variable is now like now this lamp is actually in the range, so the lamp is on. So if you know the lamp is on, we just do answer dot push back 1, because finally what we need to do is we need to return this answer variable. We not only do that, we now have to go iteratively and in this data structure proper manner, we also have to remove the elements which are around, right? So how would we do that? So what we would do is like for let's say int j is equal to -1. From j is equal to -1 to j greater than equal to 1, j plus plus. So from j -1, 0, 1. Uh, Also do the same with k. So it's like that position, one less, one more, right? For int k is equal to -1, uh, k greater than equal to 1, k plus plus. This is also be like, for this variable in -101, but stuff slightly fancier and more convenient for doing it uh, is here. So okay, in this case what we would want to do is we'd want to have this variable called all of these variables, this variable called int q. So the q x value of the q. So what is this x value of the q? It's like the q of 0 plus its neighbor, so it's j, the x, so this side and this side, right? So int q of y is nothing but q of 1, right? The y value of k plus k. So it's like the horizontal, like the vertical neighbors, right? Iterating through all the vertical neighbors. Now in for all of these, if what we need to do is, if you need to check if qx is greater than equal to 0, right? If qx is greater than equal to 0, and if qx is smaller than n, because that is the size of the grid, and if qy, right, is greater than equal to 0, and if qy is smaller than n, and what else do we need to check? Do we need to check the primary diagonals and all? I don't think so, because this is like checking whether it's valid or not. And if we see that it's like this qx qy, they are also like illuminated like in the original illumination grid, right? So yeah, so and if they are in the initial lamp list, because to check the whether they are in anywhere in the surrounding, we already put them in the if condition. And if they're in the initial this list, so s dot count is count of what, count of qx comma qi is greater than 0. That is already like it's and, so it will be a binary variable by itself. And if this is the case, then what we would want to do is we would want to do s dot erase of qx qy, right, this variable. And then we want to decrement, whether like we want to delete them, right? So we want to decrement these x's and y's, so that next time it checks in a proper way. So I decrement x of qx by minus minus. I'd want to decrement qy, because like I'm like switching off this lamp, minus minus. uh, We'd also want to switch off the primary diagonals. So like we're not switching off the primary diagonals, we're actually checking if they are switched off. We're gonna like just delete them so that they don't come in the next check, right? Qx plus qy, we just do minus minus. Yeah, we do s diagonal, you just do qx minus qy, and you just do minus minus here. So this, all of this will actually take care of the fact that the for the next time the eight around it would be subtracted, right? And if we, so this is why we are doing plus plus. We are just not noting down, whether we have just seen it once and then it's on for all. We're also doing plus plus. We're actually counting every instance of where there is also a common thing. So even if one of the common it gets in, because of the second one which is being lit, all others are being lit, right? That is the actual key part, and that is why we are decrementing everybody one by one, right, in all of them. So that's it, we are done with that. If this is the case, then push back answer one. If this is not the case, for example, if this is not the case, then you just do an else block and just say that answer dot push back 0, because it means that this condition is not satisfied. It means that the lamp is off, and if the lamp is off, we don't need to do anything now. And once that is the case, we just have to return answer. Let's do that. Let's just return answer. Right, so this is, I think, the bracket for the function. We finally, once we have done this, we finally return the answer, right, the answer vector. Yes, so let's run this code and see what happens. Accepted. Let's submit this code. Let's see whether we have made a silly mistake or not. Absolutely successful, not silly mistake. Absolutely successful. The statistics don't matter, but it's reasonably fast. So this is how you approach this relatively not so challenging but relatively insightful problem. This is one of its kind. There can be other like problems which are these rows and columns based, but this is how you solve a problem with illumination and querying, where there is updating also required while doing query. Right. Thank you. See you in the next video.